Halogens. Elements. Fluorine is very pale yellow gas, and it's highly reactive. Chlorine is greenish, reactive gas, and poisonous in high concentration. Bromine is red liquid that makes dense brown, orange poisonous fumes. Iodine is shiny gray solid and is purple gas. Trend in melting point and boiling point. Increased downgroup. As molecules become larger, they have more electrons and have larger van der Waals forces between molecules. Intermolecular forces get larger, so more energy must be put into brake forces. This increases melting and boiling point. Trend in electronegativity. Electronegativity is the ability of atom to attract electrons to itself in a covalent bond. Downgroup, electronegativity of elements decreases. Downgroup, the atomic radius increases because increasing number of shells. Nucleus is less able to attract bonding pair of electrons. Displacement reactions of halide ions by halogens. Halogen that's strong oxidizing agent will displace a halogen that has lower oxidizing power from one of its compounds. Oxidizing strength decreases downgroup, and oxidizing agents are electron acceptor. Chlorine displaces bromide and iodide ions. Bromine displaces iodide ions. Chlorine and bromide are chloride and bromine. Chlorine and iodide form chloride and iodine. Bromine and iodide form bromide and iodine. Reactions of halide ions with silver nitrate. Reaction used as test to identify which halide ion is present. Test solution is made acidic with nitric acid and silver nitrate solution is added. Role of nitric acid is to react with any carbonate present to stop formation of precipitate silver carbonate. So it doesn't do this equation, which is nitric acid and sodium carbonate forms sodium nitrate and water and carbon dioxide. Fluoride produces no precipitate. Chloride produces white precipitate and then puts dilute ammonia, so the precipitate disappears. Bromides produce cream precipitate and then put concentrated ammonia, so precipitate disappears. Iodide produces pale yellow precipitate, and this will not react with ammonia, so too insoluble. Reaction of halide salts with concentrated sulfuric acid. Halides have increasing reducing agent power down the group, and this is seen when solid halides react with concentrated sulfuric acid. A reducing agent donates electrons, so reducing power of halides increase down the group as they would have donates an electron more, because the ions are bigger, so easy for outer electrons to be given way, as pull from nucleus on them becomes smaller. Fluoride and chloride ions are not strong reducing agents, so don't reduce sulfur in sulfuric acid. No redox reaction happens, and only acid-base reaction happens to produce a white steamy fume of hydrochloric acid or hydrogen fluoride. Sulfuric acid is acid, so donates proton. Sodium chloride and sulfuric acid produce hydrochloric acid and NaHSO4. Bromide ions are stronger reducing agents than chloride and fluoride ions, and after acid-base reaction, there's a redox reaction as sulfur is reduced from sulfuric acid to sulfur dioxide. Hydrogen bromide is white steamy fume and orange fume of bromine given off, and colorless and acidic gas of sulfur dioxide is produced. Sodium bromide and sulfuric acid produce NaHSO4, and hydrogen bromide then redox reaction happens where H plus ions and Br minus ion and sulfuric acid react to form bromine, sulfur dioxide, and water. Reduction product is sulfur dioxide. Bromide is oxidized and sulfuric acid is reduced. Sulfuric acid in the acid-base reaction is an acid, but in redox reaction, it's the oxidizing agent. Iodide ions are strongest halide reducing agents. Reduce sulfur from sulfuric acid to sulfur dioxide to sulfur and then to hydrogen sulfide. White steamy fume of hydrogen iodide is given off, black solid and purple fumes of iodine are given off, colorless acid gas of sulfur dioxide, yellow solid of sulfur and hydrogen sulfide is a gas with bad egg smell. Iodide to iodine is oxidation reaction and sulfuric acid to hydrogen sulfide is reduced. Reduction products are sulfur dioxide, sulfur, and hydrogen sulfide. Sulfuric acid is acid in first step to make hydrogen iodide and then acts as oxidizing agent in 3 redox stages. Disproportionation reactions off chlorine. Disproportionation is name for reaction when the same element is oxidized and reduced. Reaction with water in sunlight. If chlorine is bubbled through water in presence of bright sunlight, a different reaction happens. Chlorine and water forms H+ and chloride ion and oxygen. Same reaction happens to equilibrium mixture of chlorine water when in sunlight. Greenish color of chlorine water fade as chlorine reacts and colorless gas is made. Chlorine and water forms hypochlorous acid and hydrochloric acid. Disproportionation reaction. Some universal indicator added to solution, it will turn red because of acidity of reaction products, then turn colorless as hypochlorous acid bleaches color. Greenish color of solution is because of chlorine. Chlorine used in water to kill bacteria. Treats drinking water and water in swimming pools. Health benefit of chlorine water is better than toxic effect dirty water gives. Reaction of chlorine with cold dilute sodium hydroxide. Chlorine and bromine and iodine in aqueous solution react with cold sodium hydroxide. Color of halogen goes to colorless. Chlorine and sodium hydroxide make sodium chloride and water and sodium chlorate. Sodium chloride and sodium chlorate are used as bleach and disinfectants.